Is a square a rhombus?
Yes.
Yeah, sure. Is a rectangle a rhombus?
No.
Could be.
It has to have equal sides.
Is a square a rectangle?
Oh.
Is a square a rectangle?
It's a special rectangle.
Yes. So therefore, can a rectangle be a rhombus?
Yeah.
Sure. Yeah. Let's be careful. The perimeter of a rhombus is 80 centimeters. The length of its diagonals are the ratio 3 to 4. Find the length of each diagonal. Okay, so first of all, let's draw. I think there's actually a rhombus drawing tool here, or close to it anyway. So if this is a rhombus right here, if we know that that's a rhombus, what do we know about each side? They're all the same, right? Correct? And what they're saying is, let me do this here. It's a segment, and let's pick a different color. Blue. They're saying that here's this side, and here is, let's say, this side right here. That's not helping me. It's going to go a little further. So there. Yeah. Okay. And I need to label some corners here so we can actually talk about this. A, B, C, and D. Great. So what they're saying is, and that's not quite to scale, of course, but what this is saying is that B over D, BD over AC is going to equal what? 3 over what? 3 over 4. That's correct. What do you know about the intersection of these two diagonals? They're what? They're right angle. Why do we know they're right angles? Because it's a regular quadrilateral. It's a regular quadrilateral. If it wasn't regular, do they have to intersect at a 90-degree angle? No, they don't.
Wait, it's regular? I thought regular had...
Sorry, not regular. I mean equilateral. Equilateral parallelogram. I'm sorry. Equilateral. Sorry. So we know that's true. So if we know that this ratio is true, what could we do to get rid of the fraction aspect of this? What could we do? Yeah, so you know that 4 times BD is equal to 3 times... Do you agree with that? Okay, so we also know that 4 times any side length is going to be what? 80. So any side length is what?
20.
20. Any side length is 20. That's correct. We also know that 4 times BD equals 3 times. Do you agree with that?
Yeah.
Are we okay with that? Okay, so I have a question for you. If, we can logic out the proof in a second, but if, let's call this center E right here. Let's say B to E was equal to X. Let's say B to E is equal to 3X. If this was 3X, can someone tell me what CE must be? 4X. Why? The ratio has to be 3 to 4. If the ratio of the whole thing is 3 to 4, the ratio of half of them, does the ratio change if you change each thing by half? For example, 8 is to 4 is the same thing as 4 is to 2. A billion to half a billion is the same thing as half a billion to a quarter billion. So is that correct?
Yeah.
What's the hypotenuse of each of these 4 triangles? No, what's the height? Well, hold on. We know that, yes, but we know that it's what?
20.
20. That's another observation. We'll do that in a second, but these are right triangles, so what formula holds? Pythagorean theorem. So you know that 3x squared plus 4x squared is equal to what?
20.
20 squared. So 9x squared plus 16x squared is equal to? Well, we'll say 20. We'll say 400. Is that okay?
Yep.
So we know that, how many x squareds do we have? 25x squared is equal to 400. So what does x squared equal? 16. So x is equal to?
4.
Technically speaking, it's plus or minus 4, but we're talking about length. So it must be the positive. So x is equal to what? 4. So if that's the case, we now know that this is 16 and this is 12. What's the question asking? The question is asking, find the length of each diagonal. What are the diagonals going to be? 32 and 24. Absolutely. Does that make sense? What ratio would still have to hold? Yeah. 32 over 24, same thing as 16 over 12, which is 8 over 6, which is 4 over 3. What did you notice? You know a 3, 4, 5 triangle is our nice Pythagorean triple. So if it's 3x and 4x, this has to be 5x.
Right.
So we also know that 5x is equal to 20, so x has to be equal to 4. That's another observation, because you know that if it's 3 squared and 4 squared, the next one has to be
5 squared.
Does it matter that those x's are tacked on? No, but it's the same thing tacked onto each one.
Right.
If it was 3x and 4x times 4x squared, is that the same thing? No. 3x, 4x, the ratio is 3 to 4, so the last one has to be 5.
And the area is 6. It's so ironic.
Yeah, that is pretty cool. Okay. Okay, so what are they telling you here? They're telling you that if you have this rhombus right here, that's not helpful. That's not a good rhombus, is it? Why isn't that a good rhombus?
It's a side length.
Different. Yeah. So we know this is true, right? So if we connect these, we know that one is A and the other one is B. They intersect at the midpoint. So what does each base have? The base has to be, so this would be A over 2, and this is B over 2. That's A over 2, and this is B over 2. How many congruent triangles are in that?
2.
Well, I see 4.
Oh.
I see triangle 1, 2, 3, and 4. Does everybody see 4 triangles there?
Yep.
4 congruent triangles. What's the area of one of them? 1/2 base times height, because they are right triangles we established.
Right. Yes.
They are.
Because
No?
yes, they are bisect.
Okay, hold on. They bisect. Yeah, they bisect, right? So that's the area of one of them, but how many are there? 4 of them. So what do we end up with? 2 times A over 2 times B over 2. So what's that equal? AB over, but that's the area, right? What is this asking for?
Perimeter.
Perimeter. Okay, so the perimeter, you have this side. How many of that side do you see? I see 4 of them, right? This is a right triangle. That's the hypotenuse. So how do you find the length from A? So I shouldn't use A, should I? How about G to H? How do we find that? Well, we know that A over 2 squared plus B over 2 squared has to be what? GH squared. So what do we have here? A squared over 4 plus B squared what? Is equal to GH squared. What do you do to both sides? It's square root. I know, we're trying to isolate GH. We're not trying to...
How'd you get that first equation? Sorry.
Because it's a right triangle,
Okay.
and you know it's, the base is A over 2 and the height is B over 2. And this is G and this is H. That's fine. Totally valid question. Okay, that's nice. So, we're trying to isolate GH, so what should we do to both sides? Square root it. We have a common denominator, so what could we do to that fraction?
Combine them.
Yeah, so you have A squared plus B squared over 4. And what do we do to both sides? There it is. I have a question. Why don't I take the negative? Because what? Because it's length. Length is always going to be positive. But that's one side. How many sides are there?
4.
So the perimeter is going to be how many times that? 4 times A squared plus B squared all over 4. Now, is that almost what they want you to show it equals? Is that close to?
Yes.
It's close, so I'm going to show you what you need to do. This is the same thing as 1/4 times A squared plus B squared, right? Do you agree with that?
Yep.
This is the same thing as 4 times the square root of 1/4 times the square root of A squared plus B squared. What's the square root of 1/4? A half. So what do you end up with? 4 times a half. Again, why don't we take the negative? Because it's length, it's always going to be positive. But what's 4 times a half now? 2 times square root of A squared plus B squared. Is that what they want you to show?
Yep.
Yeah. This is a great question. Can you what?
Head.
Pick it up into individual triangles. Instead, I'm going to add something on. What's the outer shape?
Square.
It actually turns out to be a square. 6 by what? 6. So what's the whole area, the big thing right here? 36, but then you take away this one, and each of those. Each of those is a right triangle. So is it easy to find the area of those? Yeah.
And you don't have to get
Okay.
complicated because it's just you count those little rectangles and half of it.
Exactly. Exactly. So like literally, this is what, a base of 5 up 1. This is 1 and this is 5. This is 1 and this is 4. This is 2 and this is 5. So the areas are going to be 2, 5 over 2, 5 over 2, and 5 because it's 2 by 5, right?
Oh, yeah.
Do you see them right there? So it's going to be minus 2 minus 5 minus 2 times 5 over 2. So you end up with 36 minus 4 minus 9. Sorry, no. 36 minus 7 minus 5 equals 36 minus 12, which is 24. Does that make sense? Cool. All touching circles are tangent, meaning they just touch at one point. And the radius of the 4 small circles is 1. What is the area of the shaded region? Well, can you find most of the area of the shaded region pretty quickly?
Yes.
Sure. You can find which part of the shaded region pretty quickly, Sanborn? The circle. You know that this circle, and I'll make it red so we can see it. This circle, if that's the center, what's the radius? 1. So the area of the circle is pi times 1 squared, which is pi. That's great. So we have the circle, but now we have the little like Batman thing, kind of, right? What's one way you could describe that Batman shape? What's one property of that shape? It is, hold on, no, not numerically. Hold on, not numerically, but if you had to describe this shape, I'll give you a hint. What happens if I did this? Yeah, it's symmetric across that line, right? Do you agree with that? So if we found just part of this, what could we do with that part of it? Yeah, we could find the area of this shape and then multiply it by 2. Do you agree with that? Yeah, ish, something like that. Anybody want to help me? What could I do, Missy? That's fine.
Okay, so, I drew the boxes around the circle.
I didn't even record any of that. Oh, man.
Ah,
So to recap, we'll say it again. We find the area of the big circle
by finding Batman.
by finding the big circle by drawing the square right here. We then found the area of the diamond. Adding the diamond plus the 4 small circles and taking that away from the big circle, we got 4 times Batman. And how many Batmans did we really want? So we took 4 Batmans and we divided by, and what we're really looking for is 1 small circle plus Batman, which gave us
The area.
the area. Yay! Clap, 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 clap. The number radical 2, so square root of 2. What do you know about it? Yeah.
If you square it, it equals 2.
Correct. Good. What else? Yeah. Nope. Close. No, it's real. Why is that a real number?
It's above the
What'd you say, Jackmo? Yeah, it's on the number line. On the number line. So it must be real. Where does it live? Well, here's 1. Here's 2. Where is it? Somewhere in there. It's somewhere between 1 and 2. Do you agree? Has to be. 1 squared is 1. 3 squared is 9. 2 squared is 4. Somewhere in there, right? Do you agree with that? Okay, so here's the deal. So it's a real number. The real numbers can be broken down into 2 sets. A real number is it's either what or what. It's either rational or irrational. What does rational mean? You can write it as a fraction. If you want to remember that, everybody, that's a great answer. Ratio means it can be written as the fraction of what? Of integers in most reduced form. So for example, is 3.5 a rational number? Why?
Because it's above 0.
No, it could be negative. It doesn't matter if it could be negative. It can be written as a fraction. What fraction? 7 over 2, 13/4, right? What's the most reduced form? 7 over 2. What about 2.7? Is that a rational number? Yeah, 27 over 10. What about 999.99?
Yes.
Well, that's 99,999 over 10,000, right? Can you write any decimal that ends as a fraction? Sure. So if that's a rational number, what's an irrational number? Nope. 0.3333333333333333 is rational because it's 1/3. What's an irrational number?
Pi.
What'd you say? That is an example of one, but what'd you say? Stop saying decimal. Can't you say no decimals in this answer? Okay, what's a rational number?
Can be written as.
What's an irrational number? Cannot. First of all, it's real, right? Cannot be written as a fraction. If a decimal ends, is it definitely rational? Yeah. If a decimal doesn't end, is it definitely irrational? No. 0.3333 repeating forever is 1/3. Agreed? Okay, so let's talk about root 2. Comes up, you have a, if you discover the Pythagorean theorem, which many cultures have, and this is 1 and this is 1, and this is a right triangle, what's the hypotenuse have to be? So the length exists. It's a real number. Are you okay? It's a real number. What about, is it rational or irrational? Well, how many digits would we have to look at? A lot of them. So ready, we're going to do something here. I'm going to assume it's rational. Is that okay? Let's assume it's rational. Assume root 2 is rational. Yay, assume root 2 is rational. So if it's rational, what does that mean you can write it as? In most reduced form. Root 2 equals, let's say, p over q, where p and q are what? Integers. And if it's in most reduced form, what's the relationship between p and q? Yeah, wow, good job knowing that. Where p and q are, what does relatively prime mean, Jack? They have no common factors. Is 13 over 4 the most reduced form? Sorry, 14 over 4. Because they both have a common factor. What? 2. Do they have to be prime numbers to be relatively prime? No, they do not. They do not have, because 14 and 4, they're not prime numbers, right? They will not be prime numbers. I'm sorry, that's what I was meant to say. Okay, so p over q, root 2 is a rational number, so there is p and q so that I can write it like that. Okay, that's nice. Could I multiply both sides by q? Is that okay? Q root 2 is equal to p. Sure, still true. Do you agree with that?
Yes.
Is it legal for me to square both sides fully? Is it still true? Is it still a true statement? If 4 equals 4, if I square both sides, is it still true? Yeah. So what does the left side become, Will?
Q squared.
2q squared equals, what's the right side become? P squared. Let's look at the number p squared. P squared is going to be a number. If you square a number, what do you know are two definite factors of p squared? P squared is equal to 2 times q squared. So what's one of the factors? 2. What's another one of the factors? And q squared. And also 2q is a factor, right? What can you tell me about p squared? Is it even or odd?
It's even.
P squared is even. Why?
Because 2 times the number equals 8.
Because 2 times the number equals p squared. Does everybody see that? 2 times q squared is equal to p. So p squared has to be even. What's an odd times an odd? Really? 49. 3 times 3 is 5 times 5. 9 times 9. So do you believe me that an odd times an odd is a? Yeah. What about an even times an even? Yeah, it's definitely true, right? 3 times 3 is what?
9.
3 is odd. 9 is
Oh,
odd.
I thought you meant, I was thinking like this.
Okay, so do you agree with that? I'm not going to prove that, but do you agree that an even times an even is an even? And an odd times an odd is an odd? So if p squared is even, what does p have to be? No. Odd times an odd is an odd. Even times an even is an even. P squared is p times p. So therefore p must be what? Is everybody okay so far? P must be even. Are we okay with that? Are we good so far? Haven't gone to the punchline yet. There is a punchline. If P is even, what does that mean? What does it mean when P is even? What has to be a factor? Do you agree with that? If P is even, 2 has to be a factor. So P is equal to 2 times some number K. Do you agree with that? So let's substitute it back in up here. What do we get? 2Q squared is 2K squared. 2Q squared is equal to 4K squared. What could I divide both sides by? 2. And what do I end up with? Q squared is equal to? You agreed with that? Okay, so if Q squared is equal to 2K squared, Q squared must be what? Even. Hey, same logic before, right? If Q squared is even, what does Q must be? Do you agree with that? So therefore, that's what the 3 dots mean, therefore. If Q is even, what's a factor of Q? 2. So Q is equal to 2 times some number L. Agreed? We could plug this back in here, right? If I wanted to. So what do I get? 2L squared is equal to 2K squared. So 4L squared is equal to 2K squared. Divide both sides by 2L squared is equal to K squared. Hey, let's use the same logic. What is K? Stop, don't move. It's even, right? Is there anything stopping us from doing this forever?
No.
No. Okay, keep that in your mind. Do you believe me that we keep on going forever on this? It's the same thing over and over again, right? Let's throw Q is 2L, where L is an integer. P is 2K, right? What did we say at the beginning? Stop. We said this is rational, right? Which meant that P and Q are integers. What did you say here? P and Q are relatively prime. But what did we just show? No, we just showed P and Q are not relatively prime. So we just found a contradiction, which means that our original assumption is wrong. What was our original assumption, Tony?
That P and Q are relative.
No, keep going. What was our original assumption?
That even times.
No, what is our...
2 is rational.
Root 2 is rational. So if that's wrong, if root 2 is not rational, what does it must be? Done. We just proved that it's irrational.
Oh my god.
So we just showed everybody that root 2 is not rational, so it must be what?
Irrational.
Cool?
Oh my god.
Okay, so again, let's just write this down here. Your homework tonight, everybody?